Hi guys, it's time to begin the next part. In this one we'll be adding the type level literals to the Spiral language. This is a genuine language extension. It will improve the expressiveness of the language significantly, and it will be needed in order to make the HLS C++ backends a target. The HLS compilers, as you know, is in regular C++ compilers as well as C compilers, you can declare arrays, something like this. Int a, and then you pass in a statically known size. This is how you declare local arrays on the stack. And this is how it is in HLS as well as regular C and C++ programs compiled to the CPU as well as the GPU. But in contrast to the CPU and GPU, the HLS compilers also have this. I mean, they do, but the CPUs and GPUs also have this. You can put in an array size optionally into the array type, and if you do, the C++ compilers for the CPU will ignore that. But the HLS compilers won't. And in fact, they refuse passing in an array without a statically provided size. And this is a big problem for the Spiral language right now. It doesn't have a good way of expressing types such as these. And I'm guessing the same would apply for many other languages. So in order to be able to compile to these languages at all, we need these kinds of types. And for them, we need the type literals. So what we'll do is get to work on that. Before we do, let me just put in a few words on the language themes. In our previous video, we were confused why the semantic tokens weren't working properly. And it turns out I was just using an outdated theme for the VS Code editor. Let me show you what I mean real quick. You'll notice that the editor is a bit different now because I changed the theme compared to earlier. Let me show you this. As you can see now, we have the yellows and the greens, and the types are also dark green. I didn't remember this incorrectly. Let me do this, and then we can select a different color theme. For example, dark plus. The one I had previously was this one, and as you can see, that the types aren't colored in green on this. For some reason, I picked the worst possible theme. I mean, many of these are quite cool, and I'm impressed that you can just, select a different one and it will show you the changes automatically. This is quite elaborate of Visual Studio Code. I kind of like this high contrast one, but personally I don't really care too much about theming. As long as the different tokens are colored differently, that will provide visual hints as to what the variables are. So this theme is a lot better than this old one. But having it pastel color everywhere, I don't really care too much about that. So we'll go with dark modern. I just wanted to do a brief demo. I thought of maybe doing a separate video on styling, but it's not a big deal. I don't have to go concern myself with that. Now, we'll get to work on adding type level literals to the language. We have to first do it in the parser, then the type inferencer. Actually, maybe not in the type inferencer, but definitely in the partial evaluator and the code generators. So let's get started. Now I just need to figure out how the types are parsed. These are the expressions for the language. Now where are the types? These are the types, and we'll have to add a route literal something like that. We have the variable VST range. Okay, route lit. Literal, yeah, something like this. This is perfect. Now that I added this, you'll see a bunch of green in the editor tab. These are the places we will get warnings that we need to extend. This is really one of the big benefits in functional programming, how easy it is to refactor code. This is why you'd want to make your programming language in something like F# instead of Python or anything else. Okay, focus me, route lit, error, and this is just a helper function for getting the range. And the range is, just the line and the column, the starting line and the starting column plus the ending line and the ending column of a literal of a token, actually. We need these greens. Now what is this? Type case validate. We'll add this. You don't need to do anything special with the literals. The literals are a pretty simple extension to the language, but there are some nuances to it. For example, in a language with Hindley-Milner type inference like Spiral, type level literals would be useless usually. But the Spiral also has a bottom-up pass where they'd be very useful, and they don't need to change the entire type system in order to put in dependent types, so we can make use of them. With the Hindley-Milner type system, the most you can do with the type level literals is propagate them, but as it turns out, that's actually enough for them to be very useful when combined with the Spiral's bottom-up pass. I mean the bottom-up segment. We'll call it the bottom-up segment, or the real segment. The bottom-up segment of Spiral is the real Spiral. It's what the 2018 version of the language was like, completely. But the top-down segment, which has the global type inference, is a lot easier to program in. I mean, I'd prefer it if I could program in that in everything, but the HLS compilers are demanding. I can't get everything that I want so easily. Okay, now we've got rid of the greens in the parser, but we also need to change the type parser so it actually parses the literals. Type. Where is the route T? Maybe. Okay, route T. B. Okay, B. Route T B. Let's check out where these are created. Root type union. Oh, root type. Yeah. This is the type parser. I mean, it seems a bit confusing at first, but the way it works is that it first, it goes from the bottom to the top. First it parses functions, then it parses pairs, then it parses the applications, then it parses the typed applications. Compared to F#, Spiral has something called the typed application, and that's basically just when you do something like A plus B, C. If this was F#, this would get parsed as no, actually, I don't mean to do it like this. A, B, C. If this has F#, this would get parsed as this. Or maybe like this, If this has F#, the difference between this and this, there isn't any. But in Spiral, there is. So this would get, in fact, parsed as this. This is really convenient because it allows me to do something like apply members and also pass in their arguments without necessarily putting these outer parentheses. This outer parentheses, I mean. So it's quite convenient. It does tight application, then it does uphold. Okay, this is just an utility function. It doesn't do uphold, but it then parses the cases. As you can see, there's a connection between the expr tight cases. As soon as it parses that particular segment, it goes into the cases. And then it parses the cases as an union. And over here we also need to add in the literal parser. Let lit equals, oops, I meant let read lit. Is there something like read lit? Yeah, okay, let's take a look at the term parser and we'll copy the literal case from it. Oh yeah, it's probably the read value, okay. Route lit. The thing about the parenthesis parser in Spiral is that they work differently than in F#. In F# you have something like arguments like this, int, cint. But in Spiral you cannot do that. Instead, in Spiral you need to do it like I mean, I wanted to do it the same way as F#, but it was too difficult for me to do it like that for some reason. I don't remember the exact reasons why I decided to do it like this in Spiral, but it was simply easier. Otherwise, the syntax is pretty similar to F#. Okay, we have the type literals being parsed, and then what we'll do is go to the next stage. Block bundling. We have to go through everything, in fact. Okay, this one doesn't have any changes. Infer, it should have some green. Then if you're a module, this is where the Hindley-Miller type inference is being done. It is the bottom up. I mean, it is the top-down type inference part. The bottom up one is the partial evaluator. Is this some green? Route var. Wait, I simply didn't save the parser. That's why it isn't recognizing the changes. Now, yeah, now it's saying that there's some problems. We'll put it here. Route lit. Let me check out the other two files again. I mean the other file just. Oh yeah, there's some green. Okay, we need the range. Route lit. gr. Let's make it a. In case you're wondering what this function is, the blocks are all parsed individually and then combined together with the correct offsets. And this block bundling is just changing the offsets, so they point to the right locations in the final file, in the other passes. Okay. I mean, also, The F# has linear dependencies in modules, so what's defined here cannot be accessed in any of the upper modules here. The order of the files in the editor in the Solution Explorer matters. The spiral is the same way. I think this is a really good feature of F#, and it makes it a lot easier to know at a glance which modules have dependencies on one another. Let's get back to the infer module. Routelit. You should be fine to do this here. Yeah, this function is pretty big. It has a bunch of checking. I mean, if we wanted to do something useful with type level literals in the infer module, we'd have to change the type system entirely to add dependent types. And that, I mean, that could be done, but it would lose us a lot of convenience of Hindley-Miller type inference. So it lose a lot of reasons why we'd wanted a simple type system in the first place. So I don't want to add dependent types into the language for such a reason. Where is the green? Oh, right. We also need to extend the types here. Type prim type lit of literal where are the literals defined? Lit. They're defined in the tokenize module. Okay, never mind. Tokenize literal. Great. Now we've extended the type system, so it includes type level literals in the inference module as well. And we have quite a bit of green now. Okay. This function is the one that determines the kind of a type. Type literals are singleton kinds, and the kinds are basically the arity of type level functions. Only the functions can have arity of more than one, whether that be regular type level functions or type level nominals. Okay, let's move on. Okay, we have the variable substitution here. Type B. And this should be pretty simple. Where is the... Just a sec. Alright, here are the type B's. Okay, type lit. I mean, the literals can be substituted. This is just substituting a type level variable for another type, as you can see here. This is substituting the terms. What's that for? Yeah, I think this is just shortening the meta variables. It is substituting the meta variables for their actual values, I think. What we'll do, yeah, is also add tile it. Does this have metaverse? It shouldn't. Okay. Oh, this is just the printing function for them. No problem. Or maybe it is a bit of a problem. Let me think. Tile it x show I think I probably have printing functions for the literals somewhere, so I don't want to duplicate them here. Maybe in the partial evaluator. Let me check that out really quickly. Where is the thing? Oh, here is no. This is just the conversion to the primitive type. Show lit. Oh yeah, this is it. Yeah, we'll move it to infer. Okay. We have the show lit here. Open tokenize. Or maybe we should just move it into tokenize. Who cares? Tokenize. Yeah, now that I've saved it, it propagated the changes. As a compiler, F# is actually quite a bit slower than Spiral, at least when it comes to editor support. It's quite surprising that I managed to do such a good job, at least with regards to that. But F# isn't slow either, you can get used to it. Okay, I won't really dwell too much on this particular function. It's just using these numbers to tell where the parentheses should come inside the printed expressions. Okay, let's move on. Here's the next green. What is this fill doing? Route TB. It's changing them to expressions. Okay. Tile lit x route t lit rx. Except this particular case doesn't exist, so we'll have to add it. Let's just copy this one. Literal. Oops, it should be lit. Oh, actually it exists. My bad. Wait, why is it changing it to that inside the infer? Alright, in some places I think I need, yeah, in in particular in join points as well as arrays and some other places. Actually, in arrays, in join points, and I can't remember right at the moment where the type annotations are necessary, but in several places in the partial evaluator they are necessary in order to do things like closure conversion, as well as specify the type of the array ahead of time. So this is what this is for. Okay. Where's the green up here? Oh, metaverse route elite. I mean, we're putting the type literal, so there shouldn't be anything missing anymore. Yeah, there isn't any green here anymore. I think that the type information was just stale. Okay, it should be here. As you can see, now it's telling us that the type elite case is missing. Tile elite. I think just putting it here. Tile elite. As you can see, it is a pretty simple extension as far as the type system is concerned. But the reason why F# wouldn't have it is because it couldn't do anything with it anyway. Where's the green? Route TB. Now what should we do here? Yeah, we need to unify it. Okay. Oh, this actually isn't as hard as it seems, but it can get a bit involved when you are working on it. Okay, I think we're done with this module. Okay, let's move on. The pre-pass, do we need to do anything here? Did we save everything? Let's close the other tabs. Oh, close all but this. Oh, here is one green near the bottom. Route inlet. Okay. Route inlet. RX. Delete Now we'll have to also extend this. These are the expressions which get passed into the partial evaluator. They're pretty important. What the prepass is doing is converting all those variable names into indices, which we can then use to index into arrays. In the old version of Spiral from 2018, I used the immutable maps for everything, and they made the partial evaluation a lot slower. So the latest version of Spiral is actually using arrays inside the partial evaluator. I had to write this big ass prepass in order to enable that, but it was worth it. Tokenizer literal. I think this function is just for printing stuff. I think I made a... What is even this printable? I think this thing is for when I have a... for when I want to print out the expression tree without the ranges. With the range, because the ranges make everything a lot noisier. Delete of tokenize literal. Where is it? Delete x. Okay, that's for the printables. I mean, that particular part isn't something you'd ever use as an user of the language, but as a language creator, I sometimes needed it. No less so today, but in the past I did. Now, also need delete here. What is this function doing? Okay. This is propagating the variables. The symbol. Okay. We don't need anything in particular here. Delete. Delete. Whoops. Okay, now delete, I think. I think that should be it in the prepass. Oh, the next thing is the partial evaluator, and in it we'll have to also extend the type hierarchy. Y lit of literal. No. Let's first get rid of the green. The partial evaluator also has its own type printer, but its type hierarchy is simpler than the Hindley-Milner one. So there isn't as much work that needs to be done. Show lit. And I forgot to import the variable. Great. what is going on here. Tie to data. Oh, okay, this part I actually need to think about it a bit, because I'm not sure. Yeah, the type literals aren't supposed to be converted to actual data. Let me pause for a bit so I can think about this design choice. Let's assume I had time to think about it. What we'll do is just make it a type error. Easy peasy. I mean, down the line, if it turns out that this might be useful, we could extend the language further. But I mean, suppose we don't do this and make some kind of design decision ad hoc, and the users start using it, and it turns out it was a bad choice. Well, now we have a problem, because we can't change that language feature without breaking all the existing code. But now that it's restricted, it won't be a problem to, loosen the language up in the future. So we'll do it like this. If anybody wants to propagate type level literals on the term level, open an issue and we will talk about it. Maybe even add it. It isn't a big deal. Okay, here we need some kind of what is this supposed to be for? Oh yeah, it's taking the lit. It has a range. Maybe I should have just... No, I shouldn't have gotten rid of that. Definitely not. This way is great. Okay. We have the type level literals here. Oh, not bad. Let me think about it a bit. I've changed my mind. We'll extend the term level to include the type level literals. In the compilers, they'll just be erased. They'll have the same behavior. They'll have the same behavior as db and the symbol. Where is the literal? The lit of literal. And yes, this does require some various kinds of changes. Okay, no problem. In case you are wondering what all these functions are, they are how I'm doing join point specialization of Spiral. They are the part that makes that whole thing efficient. I take a term level expression and then I hash const it, and then that becomes very easy to compare to all the other sites. Okay. The type literals on the terminal level are very similar to the regular literals, except they have different behavior when it comes to join points and arrays and returning from if statements. They'll get converted to the type level literals at the type level instead of being converted to something like an integer type or a string type. Here's what I mean. This function is just taking the literal and converting it to an equivalent primitive type. Odin. As well as in the din function, it remains as it is. Is this a red thing? Is this some kind of type error? Or no, what is this? Why is this red thing? Maybe I remove something here. Yeah, I moved. Okay, no problem. I think this takes care of it in the partial evaluator for now. I'll add some kind of operation into the language in order to convert a regular literal into a type level literal later, and vice versa. But for now it doesn't matter. No. We have to go and adjust all the code generators. Those will have a bunch of green, no doubt. And why don't they? Delete. We'll have to extend the array creation in order to include an optional static value. So we'll have to extend the array type as well. I mean. The only reason for that is because C has such a painful way of declaring arrays. I mean, when you're human writing something like int x, I mean int xt, yeah, whoops. This is the easiest way. This is the easiest thing to do in the world. But when you're writing a parser, this is such a pain in the ass. It's amazing. I'd very much prefer it if all the type information was on the left side, or the right side, like in functional languages. This in between thing is the worst thing of all. I hate whoever made the C just for this. Okay. I mean, but don't I have to add something in here so it prints the type literals correctly? It's so weird. Oh. Where is it printing the types? Types are not supported in the code gen. Okay. So this we are going to have to test at runtime, it seems. No wait, the last time I tried renaming in Visual Studio it crashed, so let's do it like this. Now no. Why the hell did I do this? Which types are missing? Why apply? Okay, this should be in the code gen. Is there any other type? Why be? Oh wait, why couldn't this be in the code gen? Wait, I was wrong. These are only the types that can get defined, maybe. Oh yeah, these are only the types in the type in the term variables, and those cannot be type level literals, as they never get converted to something like a dv. Never mind. Yeah, but even so, in macros, shouldn't they be in macros somewhere? Oh yeah, here they are. Type A. Later they'll have to be in the arrays, but for now they should be in the macros. And the macros, I think, just get rid of the unprintable types. Okay, I had to think about it a bit. We'll just extend the way the macros are printed. Where are the macros again? Here's the macro. Here's the type. And it should have a bit more. Okay, now we have to go through all of this again. And maybe change how the types are printed. Type lit. Actually, for the purpose of being printed in the partial evaluator, there doesn't need to be any particular difference. I mean, this is just for printing out the errors and nothing else. Yeah, but the macros are used in the parser, so we have to extend the parser a bit. Maybe in the tokenizer. Are they? Yeah. The macros are defined in the tokenizer. Toc macro type lit var of string. Oh, where's the type? Okay. I think now we have to go over all of this again. Check out whether something else has gone wrong. Okay, these are just the regular changes. But really, where are the macros parsed? Alright, we also need to actually add something in the tokenize in order to parse the macros. Well, let me think. Macro. Inside the parser, I'm using this particular sign, the apostrophe, or actually the grave symbol for the types, and the exclamation symbol for the term variables. But we'll also need the something like a third symbol. We'll have to extend the language to include something to parse the type literals. Why do we have just a B? What is this B? With bool. Match B with term type. Actually, this should be the opposite. I mean, type literal. They're all variables. Type term. I'm not really thinking too much about the design of this right now. Var type lit. I mean, why not just passing in a peak character directly into this instead of messing with this? We'll do it inline. Type. In that case, then whatever this is. Term. Took macro terminal. Type literal. Then took macro type lit var x. Okay. I don't want to mess with trying to separate this out right now. Now there should be something in the parser, shouldn't it? Let's do a search macro. I mean, there are parser errors for these two, so shouldn't there be one for the type literal. No, the errors are right at the bottom. I'm just looking at the green on the bar, on the scroll bar. Oh, okay, where is it? Expected macro type var. Type lit var. We'll also make a symbol, a type literal. Right now, I don't have a good way of printing out the symbols in the macro because, you know, they get printed like something like a raw string, QEA. I don't have a good way of printing just QEA, which C++ tends to use for enums. So this will also be a good addition to the language. Okay, now what's next? Yeah, we need to search for the macros. I can't believe that there isn't anything other than this. Oh yeah, here. There should be something here. Oh no, why isn't there any green here? Read macro var. Is this all? Yeah, it shouldn't be all. We also need one here. Oh, what did I do? Yeah, now we are reading the macros at the terminal level and at the type level. The only difference is that the type level macros don't support the terminal level variables. Or expected macro type where? Okay, not bad. Now what do we have in the following stages? Do we need to change anything? Yeah, we need to change it here. In the next stage, what do we need to change? Some macro. Where is the macro? Oh, here. Also here. Right. Wait, maybe not. TM var. TM text. Well, the type inferencer doesn't need to make a distinction between the type literals and the regular type variables. I mean, they're all type variables anyway. The only thing you have to be careful of is whether these are getting turned into term variables somewhere, and they are. Unfortunately, they are. Okay, in that case we'll have to extend them. Is this fine? How are the literals printed? No problem. How are the symbols printed? We did that. Okay, no problem. I think that's all in this module. Next we go to the prepass. There should be some green, and there is. what is this thing? Wait, not this one. What do I do? Yeah, we need to put it here. Oh, this is just the type, the printer for the statements, I think. Wait, why is this in the? Never mind. Shouldn't this have gone away? P macro M type. This is the regular type. Why is it causing problems? Wait, I misspelled it. Lit type. We sure have to make a lot of changes just for this one single thing. I mean, this is one of the reasons why as languages get bigger, why it gets harder to extend them. Overall, Spiral is not too big yet. Lit type. Oops, there's a green up over here somewhere. Oh, here. M lit type A. M lit type GNA. Okay. Mm. Type lit var. Lit. Oh, no problem. Okay. Pretty good. Now, what is that thing in the partial evaluator? Violet. Where is it used? Oh, this is now no longer correct. dt lit x. No. What is this doing? Why macro? Right, it's turning this turn macro, type macro into what? Why macro? Right, okay, I get it. It's turning the, you know, oh yeah, but in this case, I think this is one of the places where we'd have to actually check whether this is correct. Yeah, we also need the type literal case. TM type lit, maybe lit type. Come on. A tie SA. We'll close the parentheses. I'm just wondering whether I need to do some type checking here in the partial evaluator, or do you want to do that somewhere else? Because it's a bit too much for me to check everything everywhere. And we also have join points at the type level. I think that is for the union types. Let me pause a bit here. I need to think about this particular function. Okay, let's do some tinkering. Check is tilit function y symbol y lit true, otherwise it is false. Then we'll also assert that let assert tilit if, I mean, we can just do this. Raise type error. Printf expected type got show tie a. Oh, the IDE is a bit slower than usual for me. I mean, that might be an artifact of the project being large, but it's also probably because the stream is running in the background. F# isn't usually as slow as this. Oh yeah. I went to just as X. Why am I showing A? It should be X. I mean, tilit. Will the type error go away? And it did. Now we just also need to assert it. Oh, why is it? No, wait. This should be. I changed the wrong one. Oh, now we can be sure that these type literals are what they should be. And this thing we should move outside the function somewhere. Or maybe not. We need the S. Okay, we'll do it like this. S. Partial application at its finest. Then let's put it. I mean, why not? We can put it here outside. Is this a problem? No, it isn't. Great. We'll have to do this same kind of. We'll have to do this same kind of assert in the macro here. Assert is for fuck's sake. No, wait. This should be M type. Where is the type? Okay, it's a lit type. Okay, rather than type lit. What am I doing? I'm editing the prepass. We also need to add it. CM. Great. Assert dilate S. Okay. Okay, we have the partial evaluator adjusted. We might have to do the same thing for arrays. You know, I'm leaning towards, instead of, you know, compiling to the C style arrays, maybe I can make some kind of C class which has the array size on the left side, so I don't have to bother with compiling the arrays as they usually are. Well, we'll look into that later. I'll make a special function just for printing this. Let's okay, let's do it outside. Now, what are the types here? Are there Y? Just a sec. Tuple type, tie to data. What is this tie thing? Y lit and the Y symbol. Okay. Okay. Where was I? Y lit. Y symbol. Otherwise will fail. Raise cogen error. Compiler error. Expect printf got and never mind, who cares what it is. Let's do some renaming. I can't stand this. Oh, the next is the C code gen. The way it's printing the literals should be a bit different. Oh, what is this? Okay, detail it. The C backend for Spiral has reference counting, but we are going to take it out for the HLS compiler. Because, you know, it can't allocate dynamic memory at all. It's a HLS is high-level hardware synthesis, and in order to get dynamic memory allocation, we'd have to implement some kind of module for that ourselves. That's beyond the scope of the backend at the moment. Okay. CM type lit X. Where do I put it? Maybe here. Where is it printing the literals? Oh, here it is printing them. Why is this inside of here instead of somewhere outside? Because maybe I wanted to add something to the maybe mat HA and stdfh. Whatever, we'll move it outside. C string. Oh yeah, I'm adding the, whenever a string is used in C, I'm adding the string H library. I think maybe some backends don't have it. But whatever, we can, who cares? The upman backend I'm going to remove in the future anyway, nobody's going to use that. And so we can just import it here, import string H, string C string. What is this? Or maybe it's not necessary to begin with. I'm just defining the array type as a string because I'm doing reference counting on it. What is the string H? String H. Import string H. Oh, I'm importing it globally. Okay, that's fine. No problem. But wait, if I'm turning it into an array, then just a sec, let me pause for a bit. I got damn it, this is so complicated. Let's put it back. Let's put it back. Whatever. Where was it? Here. And instead we'll move the type literal into inside. We'll probably do a separate backend just for the high links HLS targets instead of reusing this one. Wait, before we move on, aren't there any green? Should there be macros that need printing? Macro. Okay, this is being printed here. Tie macro. Oh yeah, there's some green here. I knew there was something missing. Type lit A. Type lit A. Perfect. List lit. Okay, this one is perfect. And now we also need to modify the Python congen. I'm using the NumPy arrays as the base arrays, I think, or actually maybe not. Maybe I'm using the base arrays now. It will come to me. Let's see. Forget about that for now. Let's just type lit A. Type lit A. Let's copy the seating from here. Now where is it? Where is it printing the literals? Over here. Okay. Type lit A. Why is it giving me? Why is this giving us problems? String. Oh, alright. Okay, is that it? Nothing. The macros shouldn't affect anything in the editor support part. All the information has been processed here. Let's resume. Right now there is a heat wave where I live, and I don't even have an AC. My god. If I wasn't doing a screencast, I'd pour cold water over my head and take off my shirt. Well, summer will be over sooner or later. It isn't usual this hot. Okay, where is it? No. Okay, now I think we'll just do a commit and then move on to testing. That's the best way to proceed here. Okay, let's just first test if it builds at all. I really do like this new camera. It's a Brio 500. I had to get an adapter for it, but I see it works just fine even with that. I thought maybe that since the USB-C has 20 times the bandwidth of USB-A that I run into some difficulties, but it hasn't happened. Okay, it compiled. It took 30 seconds, which is longer than usual. But, okay, where is it? Where is the publish? Publish the spiral language. Let's do it. Oh, then we'll run it here. Oh, yes, it's working. Suppose I try doing something like this. I32. Oh, there's an error. Unification failure. Got integer 32 to 32, but expected a tuple. Well, if I did this, oh, it is recognizing the type level literals correctly in all. For example, T 2 I32 equals 2. Constraint satisfaction error. Got 2 I32 fails to satisfy a number. Okay, we have to modify the printer for the type level literals just a little. Tlit. Where is the show? Oh yes, this thing here. Oh, let's recompile it. We need to shut down the extension. Let's run it again. Why is it causing so much trouble? I mean, the TSC batch is a bit buggy lately. QEA, let's do it to I32, to I32. Okay. Now suppose I did something like this to I32. Oh, failed to parse this token. If this was the real segment, it would parse it properly. Okay, there isn't much we can do with the type level literals here. In the real segment, this would probably match, but not over here. We could, yeah, we could modify the parser for the real segment. Oh, that would help. Okay, we'll do that. Norcast variable. Oh, where is that? Where is it parsing the grave? Oh, raw. T-lit. Not T-lit, but T-turn. And the raw type. Yeah, it's this. Now, how do I have it find it all the references of it for me? Find all references. That's Shift F2. No, not in block bundling. It should be in the parser. Oh, range, type expression, raw type. I think this is it. I put a bookmark here. Oh no, where is that? And this is in block bundling. Yeah, all of it should be in block bundling. Also, this is in for. Yeah, we need to focus on this thing here. And this. Small type variable, rounds. Oh, let's do it like this then. Choice. Rounds. Why is this like so? All right. Okay. Why is this causing trouble? Am I using an array? I mean, this is not a fparsec, even though it looks like it. I did my whole library that's similar to fparsecs, except it works on the spiral tokens. I wanted to tokenize the language, so the parsing is quicker. And instead of lists, I use the arrays. Okay. Yeah, now it works. I mean, instead of doing this, why didn't I do something like this? No difference either way. Also, in addition to this, now we'll be having the type level literals. Read read value. Rav T lit. I think this should do it. Okay, no problem. Let's try publishing it again. Okay. We have to terminate the TypeScript. Let's try a print static. Print static QEA, so we can see what is going on here. If I press F1 and then build this, what's going on? Basically, and this is one of the things that that's not really that great in Spiral. You can see this error trace, but right now, if you look at it, it's unreadable. So what you need to do is copy it, make a, oops, what did I do? Ctrl J, it seems flips the terminal on and off. Anyway, you copy it and then paste it into a new tab. Row types are not allowed at the terminal level. Okay, not bad. I mean, the way this could be used is to convert these things into terminal level stuff. Now, let me think about it a bit. Okay, I thought about it. We're going to have to extend the language further. Let's do that now then. And this is in fact the place that we want to do that. We want some kind of partial evaluation operations in order to convert the literals to type literals, and another for converting the type literals to literals. Lit to type lit. Let me just copy it from here. Where is it? Where is the parsing? Where is the parsing? Alright, I'm already in it. Type lit to lit. Okay. Oh, this will be an unary operator. That has a row type. Okay, great. We'll also need to implement this in the partial evaluator. Let's do that now. Where is the p-val? p eval. Tie SA. Match tie SA with violet delete X violet right, maybe we'll reuse this functionality for the symbols. Right now we have type to symbol, but we can just make it a part of the literal functionality. Actually, let's leave it in. Y symbol, D symbol, raise type error S, expected printf expected a symbol or a type literal got show type A. The type inferencer that works on a top-down basis using the Hindley-Milner algorithm and the partial evaluator both do type inference. But the partial evaluator is in fact a lot more powerful than it, which is why I'm also doing it here. The partial evaluator is on par with the dependently typed languages. In fact, it's a bit more powerful in a sense because it's open-ended. It has very open-ended types. Delete the symbol, violet Y symbol. Yeah, but you know, we can't do this kind of operation, unfortunately. Yeah, this is kind of superfluous on the in the real segment. We don't need this. Never mind. Okay, let's compile all of this again. Yeah, I meant to make it the @ sign for the type literal. Okay, we'll close the extension manager. What's going on? Whoops. Forgot to bind the variable. What's this problem? This activation event can be removed as VS Code generates those automatically from your package JSON contribution declarations. Okay. I mean, it wasn't like that in the previous versions, but since it is offering to do free work for me, I gladly take it. Yeah, this stupid thing. Oh, let's try this. What happens if we build it now? Right, let's open the terminal. And yeah, and as you can see, it brings to integer 32. Let's try 64 and make it something like 5. You might expect that we'd get a type error, but these type annotations get erased during the partial evaluation pass. I mean, the type inferencer erases them during the partial evaluation pass. But if we put them in the real segment, that wouldn't happen. For example, if we build it, now we get an error. We'll open a new page, paste it. The body does not match the annotation. Got I64, expected 2 I32. And I don't like this got I64. It should be a type level literal. I think in this case the printer is wrong, most likely. Oh, delete. Where is the delete? Delete. Wait, maybe we're converting it to the wrong thing. Are we? Okay, first let's check the type printer. If that is wrong, then that is wrong. Detail it. Show data. So I should be right, and then wait. This should have a grave sign. So maybe it's turning them into literals after all. Did I do that? I probably did that wrong. Let's check it out. Let's not save it. Lit to type lit, and as you can see, I got it wrong. Detail it. It should be detail it. Yeah, I think it detects the changes in the compiler, so that's why it starts getting confused. In fact, I haven't upgraded the TypeScript, so it's a wonder that this is happening on the newer version. Let's build the file. We'll open a new tab. Great. But why is it not printing them using a grave sign? maybe it needs to print the types. Yeah, I need to check out how I'm printing the types in the partial evaluator. Show lit. Violet. Wait, I meant to look at the ID. Hit compound, let's run it again. Let's build it. Now what is going on? Yeah, those type literals are getting printed now with the grave sign attached to them. Hooray! Okay, just spelling around a bit. We also need this kind of symbol at the type level. Let's implement it now in the parser. Okay. Oh, maybe. So this is the range. Oh, this is the choice. Oh, how was it done in that different place? Read unary op. Oh, so it's reading a unary operator then. Branching on it. And this O, is that a range? Yeah, it's a range. I just added the range for the operator. Okay. Something then. how complicated. Let's just hack it until we get it right. Type expression D. Read small type var. Row V. Row lit. Is top down equal is top down return. All right. Okay, so something like this. Oh, yeah, that's how it is. Root type defaults. What is the environment made of? Token accords. Oh, I see. That's not the environment that is getting passed in. Instead, what does this thing need? It doesn't need anything. Okay. Alright, it can read all values. What's the difference between that and read small type var? Okay, right. We need this thing. Okay. Let's have it turn. Route it turn. Okay, term expression D. Wait. We also need unary operators at the start. Where are the rounds? It has to check for one of these two operators, otherwise. Oh, wait, but it's not just for the terms, or it is actually. I keep getting confused by this. Yeah, it needs to skip the unary operator. Oh, let's just read it. Read unary op. Then we'll match on it. Actually, let's fold this inside. Oh, okay. Will match. Match A with term expression raw term. Why am I setting this to is top down equals false? I mean, there's no way it should be able to parse it anyway. Oh, wait. Let me pause a bit here so I can figure it out without the pressure from the camera. Okay, I did just a little bit. I wrapped this combinator in the environment. Now we can get rid of this. Let me just check out some of these flags. All of term is true. Root type defaults is top down. I guess we will leave this in. Okay. This should have the same behavior as before, but this we can get rid of. Actually, wait. And this, what I've been doing doesn't make sense. Lit to type lit. But this is this should be type lit to lit. So it's no wonder that it's confusing. Okay, and we're doing something foolish. Type lit to lit. Type to var. It should be a lit to type lit. And then, okay, lit to type lit. Let's not do this like so. Term SA. Then we'll reverse this. DT lit, delete, y lit. Oh, yeah, okay. This should be... this should be something like assert type lit. Okay. I'm really wrecking this thing. Okay, this is good. Then, for fuck's sake, let me undo this again. And I'm not sure what I want to do here, but my thoughts are confused. Delete, delete this symbol. This is what I meant to do. Lit to type lit. Oh no, lit to type lit. Now, what did I want to do? In here, instead of doing this, like now, I want to do something like a row type. Yeah, row type. Let r equals in okay r, then on this whole thing. Where is the closing of the parentheses? Okay, something like this. This is good. Why is it complaining? Wait, not row type, but something just like X. Oh, for fuck's sake. Let me turn this. Okay, this is fine, this is fine. Lit to type lit, route tx per. Oh yeah, it needs to be something like row turn. Row t term. Oh yeah, this is what I intended to do. And instead of reading a type expression, I wanted to read a value. How do I read a value? Unary op, skip hop, string to op. Oh no, write this. I need it. Read var. Okay, this is reading the type expression. I need the same thing, except it needs to be a term expression. Maybe there's something, some kind of case. Application type, expression type. Oh no, wait, not this thing. Next is the yeah, I need this. I need to read the expressions, perhaps. Instead of that, maybe just the value case var, case round, case lit. Case rounds. Term expression. Choice. I'm not sure whether I'd even want to bother with parsing parentheses in this situation. but I could. In this case, what do I do? Just read the root term. Oh, the next is the root term. Okay, rounds root term, the rounds root term. Term expression Rx. Okay, this is not bad. Okay, this is what I meant to do originally, because if you look here, for example, it would be a lot more more useful behavior to just fetch from the term level, to fetch a variable instead of from the type level. This is pretty much useless. If it's the type level, we can apply it just like this, using the regular operator. Now, what was that other thing? We'll remove the changes here. Where was it? I'm pressing KN, and here's the type error. Okay, I messed this up. I'm going to revert it to how it was before. It's not worth. Compare with unmodified. Never mind that. Show me how it was before. Also, we should be reading the default literal. Oh, let's do that as well. In Spiral's case, I think that the default is set to be an signed 32-bit integer. I think it was unsigned at some point. Now it should be signed. I can always change it to a 64-bit one. But that would break a lot of things. Okay, where is it? KN. Oh wait, what is going on here? On top, on bottom, what is this? Oh, I see. It has different behavior depending on whether we are in the bottom up or the top down mode. What is this skip thing? It skips it by 1. Why? Alright, right. It resets and then it skips it depending on what it is. Oh, let's try compiling this. What is going on? Show data. Not bad. What happens if you try compiling this? Let's do this. We should get a type error. Oh, the body doesn't match the type annotation. Alright. This has a for all, and this is what this 5 gets applied to. So it returns a function that's of type literal 5, and that's what gets returned. Okay, not bad. We can make the for alls explicit in Spiral. T. Oh no, the for alls are named. But yes, we get the same error once more. Oh, let's try doing something like this. A plus B. And this should probably fail because it's not a type literal. Oh, cannot apply a for all with a term. But if these weren't dynamic variables, in that case, what would happen? Which type error? Okay, what if I just tried the B? What would happen then? If I try doing this, but why doesn't this work? It should work. Right. Because the plus operator is not. Maybe if I did something like, okay, open real core, because you know the plus operators in spiral have 4 rows in them, and this ends up applying the 4 rows instead of adding the 2 numbers. So if I open the real core and take a look at import the overloaded operators, it should work. And by work I mean these 2 numbers will get added. Instead of doing this, it's better to just, you know, something like HLS C A plus B, then you just pass in C. You don't have to mess with the bottom up segment. Wait, what did I do? Yeah, it works. Okay, so we got that part done. We should add that functionality. Type lit to lit, and then I'll pass in the T. Oops, let's add this operation into the language. We'll remove this. We also don't need this. The type should be T to T. Yeah, but we first need to fix the errors. Okay. Type lit to lit. Y symbol, this symbol is better type a literal or a symbol. Got the actually meant violet a dt, or actually delete a. And yeah, this is a pretty good way of implementing, because it would be a lot harder to, I mean, at least a lot more annoying to implement operations at the type level. Let's publish this. Okay, let's use it. I mean, this type of signature isn't correct at all, but it doesn't really matter. It should compile. And if you look at the server, it should print out the result right now. We added a plus b, turned it into a type literal here, passed it as a type into a for-all, and then extracted it into a for-all. Extracted it from a for-all into a type into a regular literal. And yes, I think that's about all that we need for type literals. Let me also extend the core library. Where is the core library? We're going to the core library. Okay, we'll add it here. Converts type there or a symbol into their term equivalent representation. You know, type lit to lit for all t. Let's copy paste this. I'm going to write T. Okay, great. Now it's in the core library or spiral, and I think as far as type literals are concerned, this is quite enough. I think we have pretty much everything that we need. For arrays, I think I'm going to compile them as classes somehow with some kind of C++ magic, so I don't have to write them out in their shitty syntax on the C side. Maybe something like that would work. I mean, the HLS does have vectors already, and those are just align arrays. So, what we also need to do now is to test these things further. I mean, are they getting printed correctly on the C side and in the F# and the Python code generators? As far as Python and the C code generators, Python and the F# code generators are concerned, the type level literals aren't important, but they are very important on the C side, because they'll be used everywhere in the HLS backend. Today was a pretty fun session, don't you think? It wasn't really as annoying as yesterday, where we had to debug the communication issues between the two different components. In this one, we actually succeeded in adding the type level literals to the language, and the only thing we have to do now is test them out, as well as figure out how to do the statically typed array. I mean, we have to figure out how to do arrays with the statically annotated lengths on the C side. We're going to do that tomorrow. If you found this interesting, please like and subscribe. It helps grow the channel. I can't really imagine anybody watching all of this. Maybe some of you programming language people will find it interesting. In that case, more the power to you. I guess maybe in some distant future, or not so distant future actually, maybe like 10 years, the super intelligent AIs will be watching this, and you are really my intended audience. The stage functional programming in Spiral playlist will be a bit more on point, and we'll actually be building machine learning libraries and testing out reinforcement learning agents and making games on FPGAs. So that I think should have a broader interest. This programming language stuff is just for the ages, so that you can see that I in fact know how to program. I hope to see you tomorrow. Tomorrow we'll resume the battle.